This is a short video on the distance on the coordinate plane using Pythagorean theorem, which is a squared plus b squared is equal to c squared. And the distance formula, which is d equals the square root of x2 minus x1, that whole quantity squared, plus y2 minus y1, that whole quantity squared. On this example, I'm going to find the distance between points A and B using Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. But this is only true in the case of right triangles. So I first need to create a right triangle using the points A and B on the coordinate plane. So I'm going to start at point A and draw a horizontal line until I get to the x coordinate of point B. Then I am going to draw a vertical line from the y coordinate of point A to the y coordinate of point B. This creates my right angle. Now I'm going to connect points A and B with a line segment. The side that is across from the right angle is always called our hypotenuse, which we label as C in the Pythagorean theorem. So AB is C. Now we're going to use a lowercase a to represent this horizontal side, and we're going to count the distance. So if we start at -3, we're going to count 1, 2, 3, 4, 5, 6, 7, 8 units until we reach 5. So A is 8. Then we're going to start at 1 and count up until we get to B. So 1, 2, 3. So B here, little b, is 3 units long. So now we're going to plug them into the Pythagorean theorem. So a squared is 8 squared, and b was 3, so we're going to add 3 squared, and that is going to equal c squared. 8 squared really means 8 times 8, which is 64. And 3 squared is equal to 3 times 3, which is 9. And of course, all of that still is equal to c squared. Now we're going to add 64 and 9 to get 73. That equals c squared. However, we want to know the distance from A to B, which is plain C, not c squared. So we have to do the inverse, which is taking the square root of c squared and 73 in order to find our value for c. So we have the square root of 73 is equal to c. Another way that we can find the distance between points A and B on the coordinate plane is by using the distance formula. The distance formula is d equals the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. And the x2's and y2 come from a point, and the x1 and y1 come from a point. The first thing we're going to do is find the ordered pair for point A. Point A is located here on the graph at -3, -1. Point B is located on the graph at 2, 4. What we're going to do is we are going to label our points as x1, y1. So point A, I'm going to call point 1 because it is the leftmost point on the graph. So I'm going to label the x-coordinate of point A as x1 and the y-coordinate of point A as y1. I'm going to label the x-coordinate of point B x2 and the y-coordinate of point B as y2. Now I'm going to plug them into the distance formula. D is equal to the square root of the quantity x2. So x2 is the x-coordinate from point B, which is 2. And we're going to subtract the x-coordinate, x1, from point A. The x-coordinate of point A is -3, so we have to put -3 in parentheses. And we're going to square that quantity. Now we need the y-coordinate from point B, which is 4. And we're going to subtract the y-coordinate from point A, which is -1. And we're going to square that quantity. So now we're going to follow order of operations, and we're going to do what's inside the parentheses first. Whenever you have subtracting a negative, that turns into addition. So now, inside the first set of parentheses, we have 2 plus 3, which is 5. And we're still going to square that quantity. Inside the second set of parentheses, we have 4 plus 1, which is 5. And we're going to square that quantity. Now, following order of operations, we're now going to do our exponents. 5 squared is 25. So we're going to square 5 again, which is 5 times 5 and 25. Now we will add 25 and 25 to get 50. So the distance between points A and B on this coordinate plane is the square root of 50 units. Occasionally, they give you the location of point A and the location of point B, but do not give you a coordinate plane to graph these points on. In this case, it is best to use the distance formula to calculate the distance between A and B. So we're going to label point A as x1, y1, just as we did in the previous example, and we're going to label point B as x2, y2. Now we're going to substitute those values in for the distance formula. D is equal to the square root of x2 is -3 minus x1, which is -2, so we have to put parentheses, -2. And we're still going to square that quantity, plus y2, which comes from point B, which is -4, and we're going to subtract the y value from point A, which is 5. And we're going to square that quantity. Now again, we're going to follow order of operations, and we're going to do what's inside the parentheses first. And just as before, when we have subtracting a negative, that turns into positive. So we are going to calculate -3 plus 2, which is -1. And we're going to square that quantity. Plus -4 minus 5 is -9. and we're going to square that quantity as well. So now we're going to follow order of operations and evaluate our exponents. -1 squared is -1 times -1, which is +1. And -9 squared is -9 times -9, or +81. So the distance between points A and B is the square root of 82.